Hello and welcome back. I thought that after our last class, I should comment briefly on something to do with the ways in which we can get economic growth into a growth model. So, you may recall that last time we just needed two things to figure out how it was that we could obtain growth in this model. We have that productivity is growing by some factor gamma z each period. So zt is z0 times gamma z to the power of t. And then by just imposing that in the long run, if there is any sustained growth, well then the growth factor of output should be the growth factor of z times the growth factor of k to the alpha and the growth factor of n to the 1 minus alpha. Therefore, we can obtain this equation, then knowing that the growth factor of capital is going to be the same as output, because investment is one of the two uses of output, so it has to grow at the same rate in a balanced growth path, and this equation then implies that capital must also grow at the same rate. So then we know this, and so we plug that into there, and we get quickly the long-run relationship of what the growth rate must be like. And in here, the way this is set up, of course, growth happens if and only if there is improvements in productivity, where productivity is this thing z here. However, consider the following idea. This is an idea that's explored in depth in a paper by Greenwood, Herkowitz, so American Economic Review, and they say the following. Let's start up here. We have that economic growth here happens only due to productivity, but what if there is an additional source of efficiency improvements? And what is that? Well, we have that consumption and investment are the two uses of outputs. Great. And what else do we have? What they're going to say differently, what they're going to look at differently is the fact that they identify that in United States data, the relative price of capital declines compared to the relative price of consumption and services. So we think of this C as being consumption and services. This is investment. These are goods that are used to create new capital. Apparently over time, for any good of consumption that you don't eat, you get more and more and more and more and more and more capital. It's as though there was some other thing here. Let's call it QT, where QT is Q0 times gamma Q to the power of T. So it's as though if this Q thing goes over time, you will find that you're getting more and more and more units of capital over time per unit of investment, which of course is sacrificed consumption. Now we're going to have two different potential sources of growth. It's going to be true that from this equation, we're still going to get here, but now this is no longer true. This is our capital accumulation equation. And in order for this capital thing to have a growth factor, it has to be not the same growth factor as investment, but the same growth factor as Q times I. And what is that? Well, it's not this. Instead, we're going to have that G of K has to equal gamma of Q times G of Y. Because investment still has to grow at the same rate as output in a balanced growth path, but capital will be growing at the rate of this product, which of course, if this is the factor by which this grows, and this is the factor by which investment grows, then we get the product. So now, this equation, which resulted from us plugging in the growth factor of capital, is now suddenly going to be different. Put this in here. Now, we rearrange. This is be separated like so. So eventually this, of course, is that to the 1 minus alpha. And now we get something different. We have that output is G to the Z times this. And so now, of course, there are two different sources of growth. Improvements in productivity, as we normally think of productivity, which affects the efficiency of all resources, and the improvements in Q, which they refer to as investment-specific technical change. Because, of course, it affects only investment goods. It doesn't affect consumption goods. Now, you can show more broadly that this setup can be generated from a multi-sector model where there's actually one sector making investment goods, or rather capital, one sector making consumption, and then this GQ just ends up being the productivity wedge, or rather the growth rate of the productivity wedge, growth factor of the productivity wedge between the consumption sector and the capital goods sector. Then there are several other papers in this literature that I mention because, again, they are things that help you to have a growth model where there are potentially multiple sources of growth. And then you could ask questions like, which one is more important? Growth of Z, growth of Q. If the growth of Q is correctly proxied by the rate at which capital becomes cheaper, then you can use those data to try and look at that, which is exactly what they do in this paper. They argue that more than half of growth is due to investment-specific technical change. Now, in another paper, which I wrote with Professor Rachel Nye in the Journal of Economic Growth, what we did was we took the version of this model that's explicitly written in terms of two different industries, one which makes consumption and one which makes capital, and observed that the results might be different if you have input-output relationships between the industries. For example, what if some of the capital goods are actually intermediates used by the consumption and services sector? It turns out that can affect the results quite significantly. More broadly, of course, this opens up the idea that you could have many industries, not just capital and consumption. You could have all sorts of different things, each of which contributes differently to economic growth, and you might be interested in understanding what that contribution is. And in another paper I wrote with Professor Juliana Swan, Review of Economic Dynamics 20, what we did was we used data for a lot of different countries, not just the United States, and showed that actually the extent to which investment-specific technical change affects growth varies a lot around the world. And perhaps more importantly, what we were able to do is show that the rate appears to be something you can account for by differences around the world in the types of capital people use. In other words, if you imagine that this gamma Q varies across different types of capital, then if for whatever reason you tend to use one type of capital more than another, then the aggregate GQ, so to speak, will have a different value from someone who's using a different mix of capital. So more broadly, I just want to open up to you the idea of having multi-industry models or other kinds of models where potentially there could be multiple sources of growth as one avenue to try and continue learning more about why it is that economies grow.